Okay, so let's try and do a quick video lecture of some of the material that it would be covering if I was in town while I'm here in Boise. Let me just apologize first for my voice. I have a bad cold, and I'll probably break out coughing in the middle of this, so I apologize in advance. But we'll try and make this brief so it doesn't take a long time. I can get the stuff uploaded and you can get it downloaded, get the main information. So I want to just start by reminding you we're talking about the organization of the periodic table and the ways we use that organization to try and understand chemical properties. We've gone through all these things that I have in front of you, and the last thing we talked about down at the bottom here, special groups: alkali metals, alkaline earth metals, halogens, noble gases. I have pointed out 4 representative groups. Now, group is a column, and we're going to continue that trend because now we're going to start talking using those. Now we're focusing on the representative elements. So the representative elements are those towers on either side of the transition metals. So this, I have a periodic table on the screen, and it's one of the newer ones, so it has the columns listed as 1, 2, up through 18. But remember, when you get to the 10s, you can just knock off that 10. But what I want you to start from by thinking about what the charges are in each of these representatives. We cannot assign the charges using the periodic table to what the transition metals are. We can do that for the representative elements. So for those things that are on sorry about that. So the things that are on the left here, or things that are on the right, remember if it's on the left, they're metals and they're positively charged. If they're on the right and they're non-metals, they're negatively charged. And what group they are tells us what their charge will be. So if we start with group 1, hydrogen, lithium, sodium, potassium, rubidium, and so on, they're metals, they're positively charged, they're in group 1, so they're always going to carry a charge of +1. Beryllium, magnesium, calcium, strontium, barium, group 2, they're metals, they're positively charged, they're +2. Now I'm talking about when they're in what are called salts. So this is something from the left with something from the right. Something from the left combining with something from the right. So then we go over here to the things on the right. So group 4, 5, 6, 7, A. So these would be the nonmetals. They're negatively charged. And remember how we assign the charge on those. For example, group 7, 7 minus 8 gives us a -1 charge for group 7. 6 minus 8, so group 6, -2 charged. 5 minus 8, -3 charged. So for nitrogen and phosphorus, when they're in salts, they will be negatively charged with a -3. So let's apply that now. So we start looking at individual combinations. And we'll start with the easy ones. So we'll think about maybe sodium, potassium, lithium. They're all going to be +1 because they are in that group 1. And they're going to combine with something from the right, fluorine, chlorine, bromine. These are all elements out of group 7. Let's go back. So remember, group 7, fluorine, chlorine, bromine, iodine. They're going to be 7 minus 8, so they have a charge of -1. And we can use this information to predict the ratios in the ionic compounds. Remember, the charges have to neutralize. So if we have sodium plus combining with chloride minus, chlorine minus, sodium has a +1 charge, chlorine has a -1 charge, they will come together in a 1-to-1 ratio. So the formula we would predict for sodium and chlorine in a salt would be sodium chloride. And it doesn't matter. It could be potassium, K+, when it combines with fluorine. Potassium is still in group 1, so it's going to have a +1 charge. Fluorine will be a -1 charge because it's still in group 7. 7 minus 8 is -1, so they will also form a 1-to-1 ratio. Kf would be the formula for those combinations. Now it's just, if we were in class, I'd ask you to do some clickers right now. So we can do this. Just take out a piece of paper, write down the answer rather than doing your clicker. But I can ask you, what is the correct formula for the salt between calcium and chloride? Notice I'm saying it's a salt. And I want you to also notice, looking at the periodic table, that's something from the left, calcium. It's in group 2. That's a metal. With something from the right, this was chloride, chlorine. It's in group 7. Now from those rows, those columns, those groups, we know what the charges are. We know that calcium coming out of group 2 is going to be charged calcium 2+. Chloride coming from the right side of the periodic table, negatively charged, it has a charge of 1-. So it's going to take 2 chlorines for every 1 calcium for them to neutralize, and the correct choice here for the formula would be choice 3, CaCl2. Now let's do the same thing for strontium and chlorine. So let's go back and look at the periodic table so you don't memorize anything here. Locate strontium, and you see it right below calcium. It's also group 2, so it's going to have a charge of 2+. So strontium, 2+, and we're using the same anion, chlorine. It's from group 7, 7-8, has a charge of -1. So in this case, it is going to be strontium 2+, and it's going to combine with the appropriate number of chlorines at -1 to balance that charge. And that means that formula is going to be correct if you would choose 3, SrCl2. There has to be 2 Cl's because each one carries a -1 charge, and 1 Cr, which has a charge of, Sr, which has a charge of 2+. Okay, one more here, just as practice. So lithium and sulfur now. Lithium and sulfur. What is the correct formula for the salt? Salt means something from the left with something from the right. A cation combining with an anion. So let's go back and find lithium and sulfur in the periodic table. You don't do this from memory. You look up there, you find lithium. Lithium is in group 1, so it's going to have a charge of 1+. We go over, we find sulfur. It's in group 6, 6-8. Group 6 has a charge of 2-. So now we're going to have a formula. Lithium +1, sulfur 2-. So we're going to need 2 lithiums, 2 atoms of lithium plus to balance the charge on that sulfur. And so the correct choice here would be Li2S, or choice number 2. Now, the question could be asked, what about choice 4? Lithium 4, S2. When we form these salts, we actually always use the lowest ratio possible. So if you take Li4, S2, divide the 4 and the 2 by 2, you get Li2S1. So we always take the simplest ratio, and that means you have to divide by the smallest number and see if you can make it another whole number. Okay, one last one just to check your understanding here. Correct formula for the salt. Again, salt means something from the left, a metal, with something from the right, a non-metal. Al and O, let's go back and find those on the periodic table. So we're looking for Al, and remember it's on the right, but it's still in the metals, so it's in group 3, but aluminum's a metal, so that means it's going to be 3+. And in combination, I think this one was with oxygen. I think that's what I asked you. I can't remember now. If this is cold, I haven't taken cold medicine too, making me loopy. But if it's with oxygen, that would be O from group 6. 6-8 is 2-. Group 6 have a 2-. So we're going to have to come together in a combination that balances those charges to make it a neutral. So aluminum has 3+, oxygen has 2-, and the combination that works is if we take number 4, Al2O3, 3+ for each aluminum atom, that's a total of 6 pluses, 2- for each oxygen atom, 3 of those, that's a total of 6 minuses, and they balance. And if you see, there's no other combinations there. Okay? So that's the way you're going to use the periodic table and main group elements to determine the formulas of salts. Now I want you to remember, that works only for the representative elements. It doesn't work for transition metals. That's that in this slide, there's orange in the middle. We don't know the charge on those. So in this case, what I might do is give you a formula for a salt, and then you can use that formula to depict what must be the charge on that transition metal. Okay? But that's it for now. We'll stop right there. I'll get this uploaded. You can take a listen. Hopefully this makes some sense.